Hello, I'm Joseph Kasser, and welcome to this podcast where the AI team does a deep dive into some application of systems thinking.
What if the absolute foundational blueprint for modern systems science wasn't discovered in some high-tech 20th century laboratory? What if the source code for how reality organizes itself was drafted over a century ago by a Russian revolutionary and then, intentionally erased from history?
I mean, it sounds like a conspiracy thriller, right? You
Yeah.
have this single master framework attempting to explain the structural math of a biological cell, the orbital dynamics of a solar system, and the messy rise of a political revolution, all stemming from one forgotten mind.
Yeah, totally. But it isn't fiction. Welcome to today's deep dive. We are looking at translated excerpts from a massive, incredibly complex treatise called Tektology, written by Alexander Bogdanov.
Right, and our mission today is to take this dense, practically buried manuscript and distill it into manageable, mind-expanding insights for you.
Exactly. We're going to explore a framework that was decades ahead of modern science and look at how its laws of organization apply to everything from the physics of a magnet to the biological aging of your own body. So, okay, let's unpack this. Because to truly understand the science, we first have to understand the man and why a genius of this magnitude was just hidden from the world. Who was Bogdanov?
So Bogdanov was actually a pseudonym. His real name was Alexandrovich Malinovsky, born in 1873. And to call him a polymath almost feels like an understatement.
Right, the sources say he was a medical doctor by formal education.
He was. But he was also operating as a philosopher, an economist, a biologist, a writer, and a highly prominent revolutionary figure in Russia at the turn of the century.
Wow, he was busy.
Yeah, very. He published his massive 3-volume life's work, Tektology, which, by the way, stems from the Greek word tekton, meaning builder, between 1912 and his death in 1928.
And yet, despite writing what essentially amounts to a grand unifying theory of organizational structure, his name just isn't in any high school science textbooks. I mean, you hear about Newton, Einstein, Darwin, but Bogdanov is a ghost.
Well, the sources explain that his historical erasure was deeply, fundamentally tied to the political climate of the Soviet state at the time. His ideas clashed heavily with the ruling ideology.
Like specifically with the Marxist philosophers, right?
Exactly. They fiercely opposed his technological concepts because they harbored a very real fear that Bogdanov was attempting to write a philosophical framework that would entirely replace the doctrines of Karl Marx.
I always find it fascinating when scientific or structural theories get dragged into political crosshairs. And just to be clear for you listening, we're just reporting what the sources say here, not taking sides, but where exactly did his theories diverge from the accepted revolutionary thought of the era? Why was he seen as such a threat?
It really comes down to his fundamental view of social classes. The prevailing Marxist view, championed by Lenin, who, the sources note, heavily and publicly criticized Bogdanov's philosophy, was that social classes were defined strictly by the ownership of the means of production.
Okay, the standard view.
Right. But Bogdanov conducted his own historical review of materialism, and that led him to a completely different structural conclusion. He argued that social classes actually arose because individuals possessed different levels of organizational experience.
Wait, so was he essentially trying to, math his way out of a political revolution? It sounds like he was trying to replace violent class conflict with a structural equation.
That is a very accurate way to frame his approach.
Yes.
I mean, if you accept Bogdanov's premise that the ruling class is simply composed of the organizers of production, the people who hold the organizational knowledge, then you cannot eliminate class distinctions by simply overthrowing a government.
Or just redistributing factories.
Exactly. To Bogdanov, violent revolution was structurally inefficient. You achieve true class harmony through mass education. He argued for elevating the organizational skills of the entire society.
A concept he called proletarian culture, right?
Yes. He believed that synthesis and structural harmony were far more permanent and productive than opposition and destruction.
So he was looking at society not as this moral battleground of good and evil, but purely as an organizational challenge. He wanted to heal the societal organism, to integrate its parts rather than amputate a limb.
Precisely.
And seeing society through that lens of integration seems to be the exact catalyst for his broader scientific theory.
Yeah, and if we connect this to the bigger picture, it becomes clear why tektology is universally recognized by today's researchers as the true, unacknowledged predecessor to modern systems science.
Decades before anyone else.
Right. He was outlining these interconnected concepts while the First World War was still raging. The sources highlight that he predated Ludwig von Bertalanffy's famous general system theory, which didn't arrive until 1950. He predated Norbert Wiener's foundational work on cybernetics in 1948, and even the later work of W. Ross Ashby.
Okay, so let's get into the actual mechanics of the theory itself. If you had to define tektology for someone listening right now, how does the text explain this dynamic science of complex wholes?
Well, Bogdanov realized that structural relations across the most varied, heterogeneous fields that seemingly have nothing to do with one another, actually operate under common laws.
Like physics and biology.
Exactly. He observed that biological disciplines were isolating themselves from physical disciplines and physical disciplines from social ones. Biologists only talk to biologists, physicists only talk to physicists.
Which is still kind of true today.
Yeah, very much so. But Bogdanov argued that structural relations can be generalized to the same degree of formal purity as mathematical schemes.
I struggle a bit with that phrasing. When he says formal purity as mathematical schemes, what does that actually mean in practice?
Think about what mathematics actually is. Bogdanov didn't see math as some mystical foundation of reality. He viewed mathematics simply as the tektology of neutral complexes.
Neutral complexes.
Right. When you count objects, say, 3 apples, the mathematical laws apply, regardless of whether they are apples, planets, or electrons. The math is neutral to the physical material.
Oh, I see.
It strips away the physical properties of the object and only measures the structural relations between them. 2 plus 2 equals 4 because of the laws of organization, not because of the nature of the items being counted.
Okay, that makes sense. It's like he realized the universe uses the exact same architectural blueprints across completely different mediums. The math doesn't care about the building materials.
Exactly.
But if that's true, if a human cell and a solar system really do follow the same underlying organizational blueprint, how did humanity figure that out? I mean, we didn't start with microscopes and telescopes.
No, we didn't.
According to the text, Bogdanov traces the origin of this understanding all the way back to human labor and primitive language.
Yeah, this is perhaps one of his most compelling and unusual theories. Bogdanov argues that our ability to observe structural patterns in the universe didn't begin with abstract philosophical thought. It began with physical exertion.
Like manual labor.
Yes. He proposes a linguistic theory where the very first early word concepts were simply designations of human labor actions. Specifically, there were shouts of exertion labor interjections.
You mean like a grunt when a primitive human is lifting a heavy rock or swinging a club?
Precisely that. The sources provide a really fascinating linguistic example using the ancient Aryan root word, rag.
Rag, R-E-G.
Right. In its developed form, this root meant to break or to smash. But Bogdanov notes that originally it probably represented nothing more than a growl or a spontaneous shout made during the physical exertion of striking a blow.
Okay.
Over time, that specific vocalization was used to mark anything connected to that organizational action. It became the label for the enemy you wanted to strike, the weapon you were holding, or the object that ultimately got broken.
I follow the linguistic evolution there, but I don't quite see the leap to system science. A human smashes a rock, makes a growling rag sound. How does an internal human grunt translate into a comprehensive framework for understanding the external forces of nature?
It happens through a process of projection. Let's say those same early humans witnessed a massive falling boulder crushing a tree in the forest.
Okay.
They obviously didn't have a scientific understanding of gravity or kinetic energy or thermodynamics, but they recognized the action taking place. They recognized the shattering, the breaking, the structural change.
Because it looked like what they did when they smashed things.
Exactly. Because the only framework they had for that kind of action was their own physical labor, they applied that exact same rag root word to the falling rock. They denoted elemental natural action with the identical word used for human labor.
Wait, so our entire ability to comprehend nature is just a metaphor for our own manual labor. Are we essentially trapped by our own biology and how we view the mechanics of the universe?
Bogdanov would argue that we aren't necessarily trapped by it, but it is the inescapable foundation of human thought. This is what he explicitly calls the basic metaphor.
The basic metaphor.
Right. Without mapping our own internal physical actions onto external nature, thinking about the universe would have been entirely impossible. We literally transfer our internal organizational experience onto the outside world.
Wow.
It's the exact reason a poet might call the dawn bloody, or describe the sea as ferocious, or the spring as sweet. We only grasp the organization of the external world, by applying the organizational framework of our own physical bodies, our own pain, our own exertion.
That is a staggering way to look at human cognition. Our brains basically hijacked our own muscle memory to invent the foundational concepts of physics.
It really is incredible.
But here's where it gets really interesting, though, because Bogdanov didn't just stop at linguistic metaphors. He took these projected patterns and applied them to physical phenomena, specifically focusing on physical boundaries and moments of severe change. He introduces this concept of the tektological boundary.
Right, because his ultimate goal was to unify completely different phenomena under single organizational rules. To do that, he looked closely at the structural idea of a boundary.
Okay, give me an example.
Visualize a front line in a military conflict where two armies are in a state of absolute mutual balance. Neither side is advancing their antagonistic efforts or perfectly paralyzing each other.
A total stalemate. The forces pushing forward are equally matched by the forces pushing back.
Structurally speaking, tektologically, Bogdanov argues that front line is identical to the north and south halves of a magnetic field mutually neutralizing each other.
Oh, interesting.
Or, if you look at acoustics, it is structurally identical to the points of a standing wave on a vibrating string where opposite fluctuating motions perfectly paralyze one another. The material is different soldiers, magnetic forces, sound waves, but the organizational math is identical. Every boundary in nature, he argues, has the same structural basis: forces in mutual paralysis.
But I have to push back here because boiling water and a social revolution are brought up in the sources as examples of what happens when these boundaries break. And I struggle to see how they are structurally identical.
How so?
Well, one is pure thermodynamics, molecular heat. The other is driven by human emotion, ideology, and complex societal pressures. How does he justify bridging that massive gap?
He bridges it by looking purely at the mechanics of what happens when a system's limits are breached. This is what Bogdanov defines as a crisis.
A crisis.
In everyday language, we hear the word crisis and we immediately think of a disaster, an emergency, a purely negative event.
Yeah.
But technologically, a crisis is morally neutral. It is simply a breakdown of previous organizational limits.
So it's just the exact moment the stalemate ends.
Yes. When water boils, the thermal energy finally overcomes the atmospheric pressure, the boundary is breached, the liquid elements intermingle with the air, and a new organizational reality, steam, is formed. When a social revolution occurs, the pressure of the disorganized masses finally overcomes the paralyzing force of the state apparatus. The societal boundary is breached, the classes intermingle in conflict, and a new political reality is formed.
And the text mentions cell division, too.
Exactly. The biological division of a living cell operates on the exact same logic. The existing boundary cannot contain the internal pressure of the growing cellular material, the membrane breaches, and two new complex holes are established.
So the thermodynamics and the human emotions are just the neutral complexes filling the equation.
Yes. The structural law of the crisis remains the same.
To prove these underlying structural laws, the text points out that Bogdanov didn't just rely on historical or societal observation. He actually referenced abstract physical models, specifically the experiments of a scientist named Buckley.
Ah, yes. Buckley's artificial cells.
And I want to make sure we explain the mechanics of this, because it sounds like Frankenstein science on the surface. These weren't actual living cells, right?
No, not at all. Buckley's artificial cells were just colloidal mixtures, essentially drops of oil suspended in soapy water. But what made them revolutionary for Bogdanov's theory was how they behaved.
Because they moved, right?
Right. Despite being completely dead, inorganic matter, these oil drops perfectly recreated the principal motor reactions of living, single-celled organisms like amoebas.
But how does an oil drop mimic a biological organism? What is the shared mechanism there?
It comes down to surface tension and environmental interaction. When the soapy water environment around the oil drop changed, perhaps due to a slight chemical introduction or friction, the surface tension of the oil droplet would alter unevenly.
Okay.
This created a structural gradient that pulled the fluid droplet in a specific direction. It would stretch out, form pseudopodia or false feet, and even envelop tiny hard particles in the water, exactly the way a living amoeba hunts and consumes food.
That is wild.
Yeah.
But Bogdanov wasn't arguing that Buckley had somehow sparked actual life in a petri dish.
Far from it. The entire purpose of highlighting Buckley's work was abstraction. By watching completely dead chemical matter behave structurally, exactly like living biological matter, moving, reacting to stimuli, seeking equilibrium with its environment, Bogdanov was proving that the laws of organization apply equally to both domains.
So he abstracted the structure of life from the biological function of life.
Exactly. He demonstrated that an amoeba and an oil drop are just two different materials following the exact same technological mandate to manage their boundaries.
It's kind of like building a miniature wind tunnel to test the shape of an airplane wing. The wooden model in the tunnel isn't actually flying, and it doesn't have an engine, but the way the air moves around it proves the invisible, universal laws of aerodynamics.
That's a great analogy.
So if everything in the universe is an organization, and everything is constantly managing its boundaries and going through crises, what happens when an organization fails to manage its internal complexities?
Well, when an organization fails to integrate its parts, it breaks down. And Bogdanov formulated a very specific rule for how this breakdown occurs, which he called the law of least advantageous conditions.
Okay.
It is also sometimes referred to as the law of the minimum. Simply put, the structural stability of any given system is entirely determined by its lowest or weakest point.
Oh, the old proverb. A chain is only as strong as its weakest link. But he scales this up to encompass incredibly complex systems.
He does. Think about it in the modern context. You can have a multi-trillion-dollar global supply chain utilizing state-of-the-art satellite tracking, predictive AI, and massive cargo fleets.
Right.
But if a single localized strike shuts down one critical port, the entire global network grinds to a halt. The systemic limit of that massive global organization is defined entirely by that localized weakness.
And the sources show he applied this starkly to human psychology and society as well. He notes that a highly civilized, incredibly complex society can be completely undone by the destructive acts of a very small group.
Yes, a sophisticated civilization can drop to the organizational level of a panicked mob almost instantly.
You can see the mechanics of that clearly when he discusses individual psychology, right?
Absolutely. He uses the example of a cultured, courageous individual, someone who is highly educated, fully civilized, but when they are introduced to absolute panic, they revert to the zoological inheritance of their primitive ancestors.
They just lose it.
They yield to a panic fear just like a weak coward. The entire complex system of their advanced psychology drops rapidly to the level of its least organized, most primitive part.
This equalization according to the lowest level sounds like a constant lurking threat to any system.
It is the primary technological threat. It's why Bogdanov argued so passionately that for a civilization to survive and progress, it has to constantly work to elevate its lowest components.
Through that mass education we discussed earlier.
Right. He believes society has to master this law in the cultural sphere to avoid being dragged back into savagery by its weakest links.
Which brings us to perhaps the most mind-bending application of his theories in the text. Because when I was reading how Bogdanov applied this concept of organizational failure to human biology, it completely flipped my perspective on aging.
Oh, the aging theory is fascinating.
I think most people, myself included, just assume aging is biological wear and tear. You use your joints, your heart pumps millions of times, and like a car engine, you eventually just rust out, lose parts, and run out of gas.
Well, what's fascinating here is that Bogdanov completely rejects that mechanical wear and tear view of aging. He fundamentally disagrees with the medical researchers of his time who viewed aging simply as a gradual exhaustion or a slow depletion of some biological vitality.
So what was his theory?
According to the text, Bogdanov argued that aging is a systemic contradiction between form and content.
I need you to break that down for me. What does a contradiction between form and content actually mean inside the physical human body?
You have to view the body not as a machine losing parts, but as an organization managing complexity. As an organism lives and grows, it doesn't just get bigger. It takes in new experiences. It adapts to its environment. Its internal cells specialize to perform highly specific tasks.
Right.
It grows in what Bogdanov calls tektological variety. It becomes highly differentiated.
It gets more structurally complex.
Yes, but the catch is this. If that massive growth in variety and complexity is not perfectly balanced by integration, meaning the body's systemic ability to smoothly organize all those new highly differentiated parts to communicate and work together, then contradictions start to accumulate within the system.
Oh, I see.
The system basically becomes too complex for its own organizational framework to manage. Feedback loops start to fail. Cell signaling gets crossed.
So the breakdown we call aging isn't you running out of vital energy.
No, aging is your body losing the structural ability to organize its own increasing overwhelming complexity.
That is profound. It's not a lack of energy. It's an abundance of unorganized variety that literally tears the biological system apart from the inside.
Exactly.
And if you accept that tektological premise, your entire approach to medicine and health has to shift. You don't just look for a magic pill to add vitality or stimulate the system. You look for ways to help the system integrate its complexities harmoniously. You look for the weakest organizational link.
It completely reframes the problem.
This entire deep dive has been like putting on a new pair of glasses. Tektology isn't just some forgotten historical curiosity about a Russian revolutionary. It is a deeply practical mental model for you listening to this right now. Whether you are managing a massive corporate team, trying to make sense of the intense political polarization we see in the news every day, or just trying to organize your own daily habits and biological health, recognizing that everything is fundamentally an organizational problem gives you a profound new way to navigate the world. You stop getting distracted by the messy surface, details, the emotions, the politics, the specific materials, and you start looking at the universal structural blueprints underneath.
That is the true enduring value of Bogdanov's work. He gave us a framework to see the hidden structural unity in a world that often feels hopelessly fragmented. But this raises an important question, one that Bogdanov himself anticipated.
Which is?
He never claimed tektology was a completed, infallible theory with final answers. He viewed it as an evolving science, and he prophetically wrote that what he did not finish would inevitably be taken up and done by others. If we take his warning seriously, specifically his warning that any system that gains too much variety without integrating it will inevitably collapse, it leaves us with a critical, perhaps unsettling thought to consider about our own modern era.
What do you mean?
Well, today we live in a landscape defined by infinite data, algorithmic echo chambers, and accelerating technological differentiation like artificial intelligence. We are pumping structural variety into human society at an absolutely unprecedented rate.
Looking at this rapidly expanding digital ecosystem, we have to ask, is the modern internet functioning as an engine of human integration, binding our global knowledge into a more stable, complex whole? Or are we currently experiencing a massive technological crisis, a tidal wave of unorganized variety that we simply haven't learned how to manage yet?
I hope you enjoyed today's deep dive. Why not take a moment and join the discussion in the LinkedIn group Tackling Complex Problems. Take care.